man, this is really living.
We're committed to the art and nothing stop us, not even a train, plane, tractor, all of us as we feel the rhythm inside the marrow of our bones.
Hey guys, Spoo Kool-Aid here. I'm going to give you a quick video. Sorry about the audio again on the end of that video. I'm going to go ahead and play that on the end of this one. Hopefully this one won't last very long. I'm just going to kind of give you guys an update of what's going on with the solar wind and all those kinds of things. This right here is space weather. I take you guys here all the time. Here's the solar wind speed, guys. That's pretty fast for this particular site. Typically this one seems to be lower than the rest, but you know, that is what it is. But here is this one, okay? The speed. Now, what I want you guys to pay attention to on this one, see the graph over here? They changed that according to what the speed actually is going on. What I'm saying is the range that they show you becomes different. If the solar wind is like steadily at like 200, what you're going to see over here would be like 200 to 400, okay? But as you can see right now, it's reading 200 to 800. And the reason why they do that is so it doesn't look like a heart monitor, okay? If it was like 200, then it would spike. It would be just doing this all over the place, okay? And it would look really, really drastic, which sometimes it actually is. So I think sometimes they do that just to kind of make it not look as bad as what it actually is. But as you can see there, our wind speed's steady at like 500 kilometers per second. That's pretty fast, guys, for a steady speed. Okay, typically it hangs around 300. So it's about, well, it's about 2/3 faster, I guess, than what it typically is. And that's why we're seeing these disruptions and stuff on these models. Okay, now, something else I want to show you here real quick. Remember I was telling you guys how this thing was looking like a mountain range, you know? That's the conditions of Earth. So for the next 5 days, guys, they're predicting it to be, you know, active. Okay? Now, especially if you look down here at the velocity, this is the solar wind speed. Okay? Look where they got this thing going. They got this thing, you know, doing this little thing right here. Because right now, we are right, well, we're probably about right here. Okay? So this thing's going to steady out according to their prediction. Okay? Then it's going to spike back up around between the 4th and 5th and kind of max out around the 5th. Okay, and then it stays up there for a while. Now I'm assuming they're probably, you know, seeing coronal holes. So that over on the other side of the sun, if you look at stereo A, you can see the incoming coronal holes that's off to the left of us if you're looking at the sun. And what I will do, and if you guys look, okay, well, we'll just do this then. Let's go to ISWA real quick. And again, guys, we're seeing some pretty decent size disruptions. So we're getting like surges, but what's kind of crazy for me right now is the fact that we're getting steady speed plus these surges. We see that sometimes with bigger coronal holes, and I think that's kind of what we're seeing. So if you guys can kind of see that, this is the actual solar wind speed model. This up here is directly related to the solar wind speed, kilometers per second. That one seems to be a little bit more like, I don't know, you get a more variance of readings there than what you do on the other site. Okay, so you got up 513 there. These are just a couple captures. It's hanging right around 500. Okay, we'll take that back 100 frames and see what it looks like. But yeah, I mean we're seeing some stuff here, guys, and I do want to show you this real quick before I let you guys go and show you the model's incomplete. Okay, and what we're going to show you as what I'm going to show you guys, you know, the time lapse, the most recent time lapse at the end of this video, and I will show you guys that here in just a second. Let me go ahead and load this up real quick while we're doing this. But yeah, guys, it is this is definitely something we have to pay attention to. Okay, so what I'm going to do is I'm going to take you right here, because look at this. Obviously, you guys are going to know that that's all kinds of wrong. I won't say it's wrong, it's just active. Okay, it's very active. Now, I want everybody to understand that sometimes this stuff can be good. Okay, because if it's shooting charged ions and we're going to absorb it, it actually will strengthen our shields in the long run. Okay, that's what I mean by how the sun protects us from the sun. So when we don't get a constant barrage of this stuff, our shields start to weaken. So when our shields are weakened like that, in this weakened state, like right there, okay, and then the sun actually has like a CME or a solar flare that's Earth facing, well, our shields are weak, but then the sun shoots this big old blob of energy at us, right? And it hits us a lot harder. So that's my point with that. I just wanted to make that clear. But anyway, keep an eye up here on that. All right, that's the solar wind speed. It gets at 634. Okay, it's probably about as high as it's going to get right now. Well, it was about 650. Okay. Now, as you can see, guys, I mean, those are some good size, hits. Okay. Again, you can see how we react. Out in the front, we get really weak for a minute. Now, can you imagine if right behind this wave there was one just as big right on its butt? What would happen? Well, if we were weak out here already because of this one, well, the stuff behind it would have an easier time getting through. That's what we have to pay attention to. Now, we are fending this off. I mean, we're seeing, spikes on earthquakes and stuff, but as far as electrical grid stuff, I don't foresee any of that kind of stuff happening, guys. I really don't. All right. Now, Scott did a great article here, guys. It's about the magnetic pole shift. Okay, we've talked about this before here on my channel. I will probably be talking more about that here recently, or here in the near future. I want to keep that in everybody's mind because it needs to be. Now, this is something else too, okay, guys? We all know Dr. Albers is sick. Well, this right here is probably one of the biggest reasons. I haven't watched Scott's latest video because I just got off work. But I've been talking to him through text and stuff. But this is one of those smart meters, guys. This is what he's talking about, radiation sickness. They put 3 of these things in his yard. Okay? And it was only like 15 feet away from their bedroom. And these things put off some crazy radio frequencies and all kinds of stuff that is not good for us. Basically, it's radiation at a basic level. It could be Dr. Albers could have gotten radiation poisoning, caused this infection that she's got going on right now in her leg. Scott showed that in his video, and I'm not going to go into any more detail than that. But I would love for you guys to go over and watch this, because you guys can, if you guys see them putting these smart meters in your yards or close to your house, say something to them, make sure they don't do it, and if they decide they want to do it, or they're going to do it anyway, make them put on a guard. They have them, guys. All they do, it's like a sleeve that goes over top of these things, and it just keeps all that bad stuff in. It doesn't let it get out to where it needs, where it's going to hurt somebody, or make somebody sick. So anyway, I was going to take you over here to the earthquake real quick. Earthquake map, or the earthquake USGS. I think we had an 8 something pop off or a 6 something pop off a few minutes ago. It's like a 6.8. Well, let's go to the other one. Let's try. Let's see here what we got. Let's go to the earthquake map. Global incident map. Okay, come on. Come on. You can do it. What's this one? Let's see what that one is. That's a 5.8. Okay, that's a pretty decent sized quake. That's pretty decent actually. It looks like might have been 2 of them right there. Okay, and you got this one over here. What's this one? 4.8. These are all that's a 10. That's depth of the 10, so it's pretty shallow. Okay, and then you got this 4.2. This happened 4 hours ago. Now, for those of us that are, I'm sorry about that, guys. My battery's getting low. Live in the U.S. here. Obviously, we're looking at this. That was a 2.5, 30 minutes ago. As I'm doing this video, there's probably one underneath it here that's probably more. Yeah, 85 minutes ago, a 3.2. We see these. People think it's weird to see earthquakes here in the middle of the country. Well, it's not. If you guys go watch Dutch Sense, a lot of times the stuff that happens out here in the West is like a precursor, because that energy or pressure, whatever, will transfer over on these fault lines. And yeah, I'm not going to go into any kind of big detail there, because I'm not comfortable enough trying to explain that. Then we got these ones up here. These are all just popping off right now. That was 48 minutes ago. That one was 47 minutes ago. So yeah, I mean, this stuff is not slowing down. I can tell you that. Yeah. I did see like a bigger earthquake somewhere, though. I can't remember where it was at, though. If I find it, I will bring it to you guys. What's this one? 4.9. I think it was like a 6.8, though, or something. It was like in the sixes. Of course, USGS could have downgraded it. But I did want to bring that to you guys. I will take you over here real quick. I do want to take you over to seeds. I actually haven't looked at this yet. So let's take a look at it together. This is seeds. This is Lasco C2. Soho. Well, look at there. Yeah. Surprise, surprise. No data at all for that day yet. Let's look at stereo A. Yeah. Not a whole lot going on there. Oh, I did want to show you guys something, okay? When you guys see these things right here, you see that blip, I used to think that these things were really, really, like, crazy, okay? Something crazy that we really should be paying a heck of a lot of attention to. Well, it turns out that it's really not a whole lot of, we really shouldn't have to pay attention much to this, is what I'm trying to say, okay? That's either, it's probably the internal workings of this camera. It's just reflecting out because the light hit it just right. Or it could be energy that's actually hitting this camera. If you guys think about it, if this was out there, how big that object would be? It'd be pretty big, okay? And it would be moving very, very fast because it's only there for one frame. All right, that's 11:54. And then at 12:24, half hour later, it's completely gone. Now, this is something else I want to show you guys too. People get confused with this. This is why I think that this is probably a camera thing. Okay, that's a half hour before, right? That's the initial. And you look at that, yes, it looks like, oh my gosh, what's going on there? And sometimes there is stuff going on, okay? But they don't, they tend to take this same shape. When they take this shape right here, it's almost like it's part of the internal camera or just some sort of refraction somewhere. And I ain't saying that's exactly what it is, but in my opinion, I don't think these are nothing to worry about. And again, it's just my opinion. So anyway, over here, if you look at the core 2, right? If we go previous, they're gone, right? We go to the next one. There's the first capture. Now check this out. It's gone on the right, but it's not on the left. All right? You guys want to know why? Because this is most likely a camera problem. You're getting a shadow right here. And actually, you see that it didn't even move, is what I'm trying to say. So if you go previous and look at that, and then you see this, it doesn't even move, guys. So I mean, if that's a true image, a half hour later, and it didn't move at all, but then it's all gone like that, yeah, it's most likely a camera issue. So I wanted to bring that to you guys and show you that real quick. Now, let's take you over here real quick, because I do want to show you, let's go ahead and do this. Let's bring this picture up. Now, okay guys, this is the one I usually show you with coronal holes. This is the current image. Okay, I've said this before. This is the equator. This is the strike zone. So the Earth is right on this thing. So here in about, depending on how fast this energy comes out of this hole, it's going to depend on when it gets here. That's that model I just showed you with the big mountain range. Okay, that could change, is what I'm trying to say, because they don't know exactly how fast this energy comes off the sun until it starts hitting our detectors. All right, that's why they have to keep changing it. But the fact of the matter is, this is the equator of the sun, this is the strike zone of the Earth, and check it out, it's right there on us. We're going to get energy, but keep in mind that our Planet X object, okay, has peaked itself back out on the other side of the sun here. All right. So, like I said yesterday, if we're going to be getting energy, if the Planet X object is round about this area right here, okay, and the sun's shooting this energy out of this hole, all directions. Well, if the Planet X object is shooting cosmic rays out, look what's happening. Okay, it's overlapping here, right? So what's going to happen is, in my opinion, some of this energy from the Planet X object is going to get picked up by the solar wind stream. And I explained this a little bit yesterday in my video. And it's just going to make things a lot more intense. So, I think it could. I think that's why we see such big hits sometimes when we don't expect it. I really think that that's what's going on. It's a combination of both those energies coming together at once as it gets to our magnetosphere and our shields, and when it hits it, it really has a big disruption. We see it big time. So, yeah. But yeah, guys. Keep Dr. Albers in your prayers, guys. Seriously, she's not feeling well. I do think she might be doing just a little bit better. But anybody that sees those smart meters, okay, you see them putting them up. If they're near your house, say something. Call the utility company. Push it. Push that. Okay? Make them put a protective cover around it. You shouldn't have to pay for that. You guys can actually go buy those yourself. I think Marfugel, Adam over there, I think their prepper situation that they have going on over there, they have those things. You can actually, I'm sure you could probably contact somebody over there, and I think he has a company he works with, maybe. I can't really remember. But I don't have those in my yard yet, or in my area. So if they start, I'm sure they're in my area, but not close enough for me to have to worry about it. So, but anyway, guys, if you see those, make sure you do that, because you can end up sick. And you won't even know why. Okay? And this is serious stuff. You'll feel like you're poisoned, is what it will feel like. And you will get sick. You won't know why. You'll start running fevers. It'll weaken your immune system. And you'll get infections easier. Okay? That's typically how it goes. And, it could look like burns. It could look whole host of things. So, if you guys see those, it's a red flag, guys. But just keep in mind that this coronal hole right here, okay, here's the equator, here's the Earth. Now, I'm going to guess in about 3 to 4 days, we're going to see that energy hit us. And like I said a minute ago, our Planet X object is out here right now. And if it's shooting energy also, that energy is going out in all directions. Okay, don't just go off in a laser beam, guys. Just like when it comes off of the sun. It's like buckshot. Okay? So, wherever these two things combine, if this energy is able to get over here and picked up by the solar wind stream from this coronal hole, when it gets to us, it's going to be that much stronger. Okay? Now, again, guys, and just a little food for thought here, just to kind of give you some perspective. The speed of light, okay, it takes light about 8 minutes from the sun to get here. All right, so that we're not talking about light energy, okay? We're talking about charged ions. This isn't a solar flare, which is typically just light energy. I mean, it's bad stuff, it's strong stuff, but what I'm trying to explain here is that this is why we have to wait three to 4, sometimes 5 days before we get hit with this stuff. Okay, so I'll tell you what we'll do just real quick. I got this converter, and we're going to call it 700, okay, because I seen a reading at 700 on the wind speed. This is kilometers per second. All right, and I'm going to convert it to miles per hour. That is 1.5 million miles per hour. Okay, so if you take that, 1.5, what would we do here? Okay, yeah, here it is. The sun is 93 million miles away. Most of us believe that. There's some that don't, and that's fine. I'm not saying anything bad about that. I mean, honestly, everybody's entitled to their views. But for me, the sun's 93 million miles away. Divide it by 1.5. It's going to take it 62 hours to get here. So you divide that by 24. That gives you 2.5 days. Okay, 2.5 days from now, that solar wind that's coming off that hole right now will be hitting Earth. Okay, so yeah, so again, keep in mind, Planet X object has moved over to here, and that's why we're going to be able to see some of that energy from it. It was over here around the 29th and 30th. Now it's moved over to here. Okay. And all that, the 28-day orbit thing we've been talking about, and what we've been talking about a lot here, Scott's been talking a lot about it. Every day we get more observational evidence of this. Okay, I mean every day. So, that was in my video yesterday. Don't get much clearer than that, guys. But anyway, guys, God bless. Yeshua saves, and you can drink this Kool-Aid.